So good day, I'm Hrvoje Tkalčić from the Australian National University, and I will present the Macquarie Ridge Complex in 3D project. It's an international collaboration. It's a multi-million-dollar investment, and I'm grateful to many institutions who supported us, and in particular, I'm grateful to AuScope for their continuing support. So I would like to put this work in a broader context and explain why we are doing it, why we're interested in Macquarie Ridge Complex, what we will do, how we will do it, and I will even show you some preliminary results after the first voyage. So first of all, the motivation, why we do it. And as you can see here, Seismology and Mathematical Geophysics was a group within RSES, and this is well aligned with our research directions. In the meantime, RSES has been restructured, and now it has 3 areas. Geophysics is one of them. And if you look at my research interests that are officially stated here, I'm proud to say that this project embodies every single research interest that's listed here, including the Earth structure, including the physics of seismic sources, and the deployment of geophysical instruments in the remote areas of Earth, including oceans. So this is my research group at the Research School of Earth Sciences and how it developed over the years. And all of the current PhD students and postdocs contribute and participate in the current project. This is the team that actually sailed on the first voyage. You can see us here, smiley faces after the successful first voyage. My partners in crime are Carla Nikin from ANU and Mike Coffin from UTAS. And our international partners are Nick Rawlinson from Cambridge and John Stock from Caltech. Apart from science team, there are a lot of technicians and other support, and many of them supported us from onshore. And I'm particularly grateful to the individuals that are listed here in the lower left corner for helping us to deploy 5 additional instruments on the Macquarie island itself, and particularly to the AAD expeditioners who enthusiastically deployed 5 instruments in the harsh conditions. So the goal of seismology is to study the Earth's interior and basically to continue where geology stops. And it has in modern seismographs a sort of binoculars that enable us to look at the largest of depths. That's what was said by Andrija Mohorovičić at the beginning of the 20th century. And in a way, this is what this project embodies. You can see that we use body waves and surface waves to study the Earth structure. And you can see in this animation how some of the deepest parts of the planet are sampled. And of course, our research has this human component, and this is that the earthquakes and tsunamis are natural disasters. Can we predict them, or can we at least forecast them? And you can see some of the heartbreaking images from the historic earthquakes. The answer to that is that we cannot predict, but we can mitigate them. And here's an example from San Francisco Bay Area, where you can see that if we have a good understanding of the underground architecture, we can predict the way that the waves propagate, and we can predict the ground motion. So if we can do it in California, we can do it at the other parts of the planet. So proliferation is one of the overreaching goals of global seismology. And we have been doing this by expanding to really remote regions of the Australian continent. But now it's the time to actually get our feet wet and to expand beyond our continent to the vast Australian plate and the oceans. And here's an example of how this can be done by careful and smart deployments in the southern hemisphere. We can actually capture the northern hemisphere seismicity by deploying these ocean bottom borehole or even oceanic island borehole seismometers. And this brings us closer to home. This is the Macquarie Ridge Complex in orange circle. and its position relative to Australia and New Zealand. And this is where our project brings us. So why Macquarie Ridge Complex? First of all, you can see here from the left that this is an extremely complex tectonic setting with Australian plate on the west and the Pacific plate in the east. And this interaction between the two plates is known as the Macquarie Ridge Complex. You can see it's dominated by the right lateral strike slip. And the whole situation is complicated by the existence of the Antarctic plate in the south and this newly discovered Macquarie plate. So if you look at the historic seismicity, the 2004 and 1989 earthquakes happen a little bit further away. So they are from the edges, they are interplate earthquakes. We don't understand why they happen there. And that's what we are trying to understand. Do they have any oblique components? You can see that the 2004 quake caused a small tsunami in New Zealand and Tasmania. And for those of you who are interested in the history and planning of the funding, you can find more details in this slide. So what will we do? The main goal is to advance, or the main aim is to advance understanding of the Australia-Pacific plate boundary using the range of imaging techniques. And then armed with that knowledge of the earth structure, we can tackle physics of earthquakes and try to understand why these earthquakes happen in the Macquarie Ridge Complex area. And while we are doing this, we can also monitor earthquakes, nuclear explosions, storms, the ice-related processes, and other atmospheric and oceanic phenomena. So these are the outcomes and benefits. The most beneficial outcome is the understanding of how subduction initiates, whether there is an incipient subduction there or not. Then we will improve the volumetric coverage of the deep earth due to the unique location of the Macquarie Ridge. And this will, our deployment will allow the enhancement of weak signals due to the design that we came up with. And you can see it here. So you can see the Macquarie Ridge complex location, and you can see the design of our array. At the time I first wrote the first proposal, this was, we were worried about the weather and the waves. But in terms of the design, you can see here in this animation, it's a spatial relationship with the Macquarie Ridge itself, with its bathymetry. You can see the X-ray shape in the north and the spiral arm in the south. And you can see, you can appreciate how steep the Macquarie Ridge itself is. And these are the images from our deployment, focusing on the EGOS equipment here shown in yellow. We deployed during the night, we deployed during the day, we deployed during the stormy weather. Basically, this is the actual Macquarie Ridge arrays after the deployment. You can see that we had to improvise. We had to move the array slightly to the east to avoid these steep slopes. And this histogram here shows you the distribution of the OBS depths, most of them deployed between 4 and 6 kilometers. You can also see the island map with 5 additional stations. So this is the bathymetry result from our voyage. Again, you can appreciate the steepness of the slopes. You can see where the OBS equipment is at the moment. And most importantly, we found evidence for mass wasting, and it's actually a very significant mass wasting along this eastern flank that is between tens and hundreds of kilometers long. And we also found evidence on the other side. And just to put things into perspective, this is showing against Himalayas, Andes, and Alaska range that Macquarie Ridge is indeed the steepest wall on the planet. So how will we do it? We have experience with seismic deployments in Australia. And this is an example from New South Wales, where we studied the lithospheric structure by using receiver-based methods. This is an example from Tasmania, where we basically used tomography. We did a lot of seismic source studies, especially in the Bayesian framework, and this is going to come handy in the Macquarie Ridge environment with the rigorous treatment of uncertainty in particular. The other thing that we did is we deployed another spiral array in Australia. This is an example from Northern Territory. This is exactly the same spiral arm shape as in the Macquarie Ridge area. And last but not least, we ventured into Antarctic seismology. This is an environmental, or as I like to call it, blue earth seismology. And many of the methods that we deployed to study the cryosphere are going to be used in the Macquarie Ridge environment. So this is not the end. It's not even the beginning of the end, but perhaps it's just in the beginning of the second part. And you see that we are set to sail in November of this year with the two major objectives: to collect and to collect the instruments and to finish the mapping. And the data analysis will become in 2022. So thank you very much for your attention and stay tuned.